warahmatullahi wabarakatuh. My name is Siti Akilah binti Nur Hadi and my matrix number is S72341. Okay, so today I'm going to talk a bit about crystal defects, what they are, how they form, and why they are super important in material science.
In a perfect crystal, atoms are arranged neatly in a repeating pattern. But in real life, no crystal is perfect. There are always defects. There are three main types. First, point defect, where atoms are missing or extra ones are squeezed in. Second, we have the line defects, also called as dislocation, where a row of atoms is misplaced. Next, we have the surface defect, which appear on the crystal boundaries or surface. This defect might sound bad, but they actually affect the strength, hardness, and conductivity, sometimes even making materials stronger. Let's talk more about point defect, especially vacancies and interstitial. A vacancy is basically when an atom is missing from its usual spot. This can happen when a material is heated up. The atoms move around more, and sometimes one just pops out of the place. Next, interstitial happens when an extra atom squeezes into a small gap between other atoms. This can be caused by impurities. Even though these are tiny changes, they can have big effect. For example, we can have effect in diffusions, hardness, and density. So let's move on to the dislocation, which are line defects. These are super important because they explain how materials deform when we apply force. Basically, instead of all the atoms moving at once, only a few layers move along a dislocation line. That's why metals can bend or stretch instead of breaking right away. So, if we can control the dislocation, we can control how strong or flexibility a material is. A process like work hardening or adding alloying elements can stop the dislocation from moving too easily, and that makes the metal tougher. For example, in airplane parts or construction materials, engineers purposely design the structure to have a certain dislocation behavior so the metal can handle stress without breaking. So, to wrap it all up, crystal defects are not just a mistake. They are actually what give the materials their unique strength and properties. By understanding them, we can design the materials that are stronger, lighter, and better for different uses.